Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video, we'll look at the actual implementation of Ensemble methods. And before we do that, we'll do a quick recap on what we learned in the previous video. So in previous video, we looked at the four different categories: averaging, boosting, voting, and then stack generalization. And we looked at the intuition for each of these methods that we have listed on this particular flowchart. So in this video, we'll write the code to run each of these on the same data set, one for classifier and one for regressor, and see how the output varies. So this would be a toy data set. We'll work on the real world data set soon with all of these methods. So let's get into Jupyter Notebook and see how we can create the models for these. Here in Jupyter Notebook, I've imported several libraries, uh, including an, a tree and ensemble, and also this additional library, which is sklearn.experimental import enable underscore hist underscore gradient underscore boosting, and we'll use that to run the hist gradient boosting method. Now we also have some additional libraries for other classifiers. So what we'll do is we can combine any type of classifier and see how the results turn out. So I've listed them here. We may or may not use all of them. So let's see how we can work with this. And I have already, these are the uh, versions installed on this machine that I'm using. Now, first we'll create two data sets, which would be simulated data sets, and these would be for classification and regression. So for classification, uh, let's create one here. So for classification, we have classifier. We'll have XC and then YC. I'm adding the C because just to differentiate it from regression. Data sets dot make underscore classification, and this is a real easy way to create toy data sets by using the make underscore classification. We'll have 1,000 rows and 50 columns. So samples is 1,000, features is 50, and number of classes will set it to just 2. So that's our data set, and we can go ahead and split this data set into train and test set. So xc underscore test and yc underscore train yc underscore test is equal to train underscore test underscore split, and here we have xc yc, then stratify is equal to yc, and shuffle is equal to true. So with this, we can also print the shapes. So print xc. So why don't we copy this? So what I'll do is copy this, paste it here, and then just add the word shape in front of all of them. So xc test, and then yc train, yc test, and let's see. Okay, so that's a mistake. And so this is the data we have. Okay, once we have an error, classification, that's again my typo. Oh, there is another error. Keyword argument, number of samples, there should be an S there. Okay, finally. So this is the data set we have, and now we can create a similar data set for regression. So instead of classifier, I'll just use the regressor, and instead of make classification, here we can write regression, and again the number of samples and features stays the same. We do not have number of classes, but we do have targets. So we'll set just one target, which is y, and instead of having c, the letter c, because this is a classifier, I will change that to R. So that, yeah, so that's R. I'll change all of these to R, so that when we use this would be for the regression, and we do not need the stratifier, so I'll delete that. And again, this would be XR train, XR test, wire train, and wire test. So let's check if everything is okay, and now run this. And that is for regression. So we can look at X train. So that's how the train looks like. And then YR train. So those are numbers. And if we change that and see YR test, those are ones and zeros. And if we look at XC train, those are the numbers we have. Okay, so now we have the data. Let's begin with classification. So classification, and here we'll use our usual method for running different classifiers is by creating a list of all the models we are going to use, and that just makes it easy. So we'll create a list. Model underscore list is equal to in the tuples ensemble dot, I'll copy this word because we'll be typing it over and over. The first one is bagging classifier, and here we need to specify the base estimator. So the base estimator will set it as linear underscore we'll use the ridge classifier. So ridge classifier, and the number of estimators we can set it to n underscore estimators. So how many trees we want to build, let's set it to 20. And then we can specify the name here. So for name, this would be bagging classifier. And the next one after this is random forest. So we have ensemble random forest classifier, and we'll use the default values, the random forest classifier. And after this we'll use ExtraTreesClassifier, ExtraTreesClassifier, and again name that ExtraTreesClassifier. And next we have AdaBoost. So AdaBoost, AdaBoost classifier, and again name that here AdaBoost classifier. And after this we have the gradient boosting classifier, so we'll add that, a gradient boosting with ing classifier. And this is again gradient boosting classifier. And then we have hist gradient boosting classifier, so histogram based hist gradient boosting classifier. And again the name for that hist gradient boosting classifier. So these are the classifiers we have, and let's run that. So that looks okay. Now we'll create the function to fit each of these classifiers. So we'll name it fit underscore model, and that takes in the classifier we have in the list above, and then just performs the fit on the XC train and YC train. And then we get the predicted value YC pred is equal to CLF dot predict, and this would be on the test set XC underscore test. And finally we can get the accuracy score. So matrix dot accuracy underscore score YC underscore test YC underscore pred, and then we can print the accuracy. Accuracy is equal to ACU. Now we have the function. Now let's run through the model list and call this function. So for CLF name in model underscore list, to make this another, So we are going to create a similar list for regression. So I'm going to rename that as model list CLF, just to make sure that it's a different name. Then we can add some lines here for printing. So just so that we can visualize easily, name, and then again print, add a hyphenated line there, times 50, and this should be in outside of the quotes, so delete those. Now we can call the model fit underscore model CLF, and we can print a new line to separate the output. So let's run this. Here is the output for different types of classifiers. We have BaggingClassifier, which has accuracy 0.87, RandomForest 0.9. These are ExtraTrees is 0.9, AdaBoost is 0.88, and then we have gradient boosting 0.89, gradient boosting is 0.90. So they are pretty close. And when we apply this to another data set, these can be, the parameters for each of these can be tuned using cross validation, so so as to improve the accuracy of these models. So that was classification. Now let's look at regression, and for that I'm going to copy this entire list and paste it here. So we have regression, and for regression the list is going to be reg, and we'll use the same sequence. So the first one, instead of classifier, now we have regressor. So I'm going to change those words, regressor, and base estimator is, instead of ridge classifier, this would be just ridge. We could also use any other regressor, doesn't matter. Then for random forest classifier, this would be regressor. Again, this would be regressor, extra trees or regressor. And then for AdaBoost, again, this is regressor. So having this in such a nice standard naming format helps a lot. So you can simply change the classifier to regressor, and now you have now you can use that to perform regression tasks. So this is the list for regression, and as before, we can now copy the rest of the code, which is the function, and then we have the loop, which is the for loop. Now for function, this is going to be different, so let's add reg there. I'm going to add reg there as well, and this is going to take xr and yr, and similarly for the test, it's xr and predicted is yr. And instead of accuracy, we are going to calculate mean squared error. So mean underscore squared underscore error, and here we have yr test and we have yr pred, and this would be MSE. Again, this would be MSE. So that's the function we have here. So we have the updated function. Now all we need to do is change some things in this loop, and we are ready. So we have reg there, and here we can change this to reg. Now we also need to change these. So this would be reg instead of CLF. Again, this would be reg, and then we just change the name of the model to reg. So change that. Now let's try to run this and see how it works. So we are seeing the MSE score, and at the very first look, we can see that the MSE for the BaggingRegressor is much lower as compared to all of the other three regressors. We won't go into the details of why that is in this video, but that's something to note. So using these forest regressors, maybe they can be tuned to bring down the MSE significantly. Right now we are running them based on just the default values that are there in each of those regressors. Now let's look at stack generalization. Stack generalization, and what stacking helps us do is we can stack the output of previous ensembles and put them as an input to a new ensemble or new classifier. And here we'll first look at just the stack, one stack, and then we'll look at stack of stacks, or two stacks together. So this is, we'll create a list of regressors in this case. So estimators is equal to, we'll use the ridge and linear underscore model dot ridge. Then we have linear, so I'll use linear regressions, linear underscore model dot linear regression. And after that we have KNR, so neighbors dot k neighbors regressor, and we'll start with these three, and then the first we specify the estimators for the stack, and then once these are evaluated, the output of this would go into the final estimator, which is this one, ensemble dot gradient boosting regressor. And then to fit, we can specify it in this way: reg is equal to ensemble dot stacking regressor, and here we specify estimators is equal to estimators, and then the final estimator is equal to final estimator. And with this we can then use the reg to fit, reg dot fit, and this would be on the xr underscore train, yr underscore train, and then we have yr underscore pred is equal to reg dot predict xr underscore test, and then we have msc is equal to matrix dot mean underscore squared underscore error, and then we have yr underscore test ir underscore pred, and then we can get the MSC. So when we run this, linear model is not defined. So let me go back up and run these again, because I had to restart the computer. So we have this. Now this should work when we run this. Stacking regressor, of course it needs to be a small e there. Final estimator, that's again my spelling mistake. Okay, so we get an MSE of 10.88, and so the way this works is we have these initial estimators, and the output of that estimator is then used as an input to the gradient boosting regressor. And to make all this work, we input that in this ensemble dot stacking regressor. So here are the previous estimators, and here is the final estimator that takes the output of previous estimators as the input. And the run is pretty standard: fit and then predict. Now let's look at an example of how we can use stack on stack of stack. And for this we are going to use again the same data set, and we'll continue using the regressor. So what we'll do is we'll create a new set of final estimators. So these final estimators, will create 3 of these and then use them as input to another final estimator. So final underscore estimator underscore 1 is equal to ensemble dot gradient boosting regressor, and then I'm going to copy that 1 2 3 and then run this 2 this 3, and for this part then we can use random forest. So I'm going to change that to RandomForestRegressor and then change this to AdaBoostRegressor, and we can put all of these in a list. So estimators 2 is equal to the first one is let's call it GBR. That's because it's the gradient boost. So final underscore estimator underscore 1, and then copy this and paste it 2 times. So we have 2 names coming up, and for this one this is going to be RFG, random forest RFG, and then this one would be ABR, and let's rename this to 2 and rename this to 3. So with that, now we can create a final estimator. So final estimator is equal to ensemble dot stacking regressor estimator is equal to estimators with a S, estimators underscore 2, because that's the list we are using in here as an input. And then final estimator is equal to linear. So we'll just use a linear model linear underscore model dot rig. So that's our final estimator. And now this is the new items that we are going to stack. So the previous items would have been these estimators. So what I'm going to do is simply copy all of this, copy and paste it here. So we have estimators, ridge, linear, KNR. Then we have this up there, which is a new one. And then we have ensemble stacking regressor, and estimators is equal to estimators. Final estimator is that one which has a ridge in it, and it takes in those values. So overall we have 1 2 3 then 4 5 6 and then 7. So we have 7 different layers on this. Now when we run all of this, we should get an output. So we get an output where the MAC is 20.65, which is higher than before, but this is just to show an example of how the stacking generalization works. Now moving on, let's look at how voting classifier works. Voting classifier, and for this we'll use 3 different types of classifiers. So CLF1 is equal to ensemble dot BaggingClassifier, and here we'll use a base estimator which is ridge classifier linear underscore model dot ridge classifier. We could use any other classifier as well here. Then the second one I'm using naive base, naive underscore base dot Gaussian naive base, and then the third one is ensemble dot hist gradient boosting classifier. And for then we can create a list of estimators. So estimators is equal to here we have BR for the first one, so CLF1, and then copy all of this and put it down below. Sorry, so this should be copy, paste it here, paste it here. So now this is LR and this is HGB. So this is CLF2, this is CLF3, and we have the final ensemble ECLF is equal to ensemble dot voting classifier with a capital V and C, estimators is equal to estimators, and then ECLF dot fit YC. So XC train, YC train, and then we have YC pred is equal to ECLF dot predict XC underscore test, and then we have the accuracy ACU is equal to matrix dot accuracy underscore score, and we have YC underscore test, YC underscore pred, and then ACU. Now when we run this, we should get the output. So this is accuracy of 0.86, which has 3 different classifiers, and the way voting classifier works is takes the output of each of these for each sample and takes the majority vote to assign that sample to a particular class. Now next, let's copy this, is voting regressor, and for voting regressor again we'll use the same format. So here, except of this, we'll change this to reg1, this will be reg2, and we have reg3, and instead of classifier we'll just use ridge, so that would work for regressor. And then instead of naive Bayes, I'm going to use linear underscore model dot linear regression, and for hist gradient boosting, this would be regressor. And finally, this would be LR HGB. It shouldn't matter if we have those names. I'm going to change these to REG, and now we can again rename these as well, and this would be R, and this would be R. Again, this would be voting regressor, and we have those estimators there, and EREG, and again this would be YR pred. And then finally for metrics, we have matrix dot mean underscore squared underscore error. Here we have Y test, YR test, and then we have YR underscore pred, and we calculate the MSE. When we run this, we have an error. So let's see what the error is. Estimator a bagging classifier. So that's my mistake again. I should have seen that. Regressor. And so now we have output where the MSE is 383. So this could be tuned further to get a lower MSE, or these regressors could be swapped depending on the type of problem. And so I hope in this video you got a hands-on experience on using different types of ensemble methods such as bagging, forests, gradient boosting, AdaBoost, voting classifiers, stacking methods to either classify or perform regression on a data set. And in the previous video we looked at the intuition about this, all these methods. I hope you'll be able to apply these to your projects in real world data sets as well. We'll use these in one of the future video projects too, so you get an hands-on experience on that as well. Please like, share, and subscribe. I hope to see you all in the next video. Until then, thank you.